Hey everybody, welcome to the Daily Space Weather. I'm your host, Dan, aka smAsho. Today we'll be talking about more protons, the Solstice countdown, and how the Greenland ice sheet could be melting. Oh my God, I'm very scared. Are you scared? Are you frightened? Are you spooked? Have you been fear-mongered on YouTube? First thing we're going to do today is look at the local yellow dwarf here in colorized magnetogram to see another active region rising in the southeast. It was not a sunspot when we did show prep. At least none was visible. And we'll zoom in on that real quick. There you go. There's that active region. Also, there is a bit of activity going on at sunspot 2786. Next, we'll take a look at the radio flux, which, by the way, is at 105 solar flux units. And Epic Pen, you're failing me again. I don't know what is going on with Epic Pen lately. Hey, Epic Pen, update your software. Here's a graph of the radio flux, as well as the sunspot number and the AP, the planetary index, planetary A index. And we've seen a little reduction here in activity following a massive uptick in activity. And the radio flux is actually way up here above 100 at levels we haven't seen since 2015. We've got some fantastic HelioViewer movies for you. We're going to save those for the end of the video today. And today's Smash Lights segment will actually be probably a live stream following the live premiere. And thanks and cheers to everybody who views the premieres. Cheers to those at the premieres. I would also invite you all to visit the Discord channel and other links below the video. And I'll give you a moment to press like and subscribe. Thanks to our new subscribers over on YouTube. If you haven't seen our smAshomash.org presents the Sun series yet, go check those out. There are 9 videos. You can link to those at smAshomash.com. They're on the homepage except for the latest one, which you can only link to at youtube.com/smAshomash. And we'll gladly just wait for you here to press like, subscribe, the notification bell, and how about pressing share and sharing on your social media? Do you have like 5,000 Facebook friends? Tell them about the channel, as we need your assistance to get our videos out there. We're going deep dive into the data on the daily. Also, I would recommend everybody follow me on Twitter if you've got a Twitter account. There are also other social medias there. Thanks to our BitChute users, approaching 260 subscribers over there. And we are streaming live at twitch.tv/smAshomash, my favorite live streaming platform. Thanks to all of our Twitch subscribers. And we'll have a little bit more about the links you can visit below the video, supporting the channel, and so on. First, we're going to talk cosmology, as another interesting story has come out. We're going to be talking about orcs. Yeah, orcs. Right there is an orc. No, it's not a Dungeons & Dragons monster. It is an odd radio circle. Now, you may be thinking, oh, that's probably a supernoval remnant, right? Well, it's not, as there's no indication that there's anything supernoval creating that. You're thinking, oh, maybe it's a jet from a galactic core, right? Well, there are no galactic cores anywhere near there or any jets appearing to point toward that. Maybe you're thinking, oh, it's just a jet from a star, right? Well, there's no indication of that either. It is just an odd, roughly circular cloud of radio emissions, and it's not understood at all where they came from. There's an article on it at phys.org in the Astronomy and Space section. Odd radio circles, yes. This one's been identified as WTF. Again, we don't know where they came from. Another interesting aspect of cosmology covered here during our cosmology segments. And we've got more cosmology stuff to talk about. I'm going to let the article scroll. Again, that is at phys.org in the Astronomy and Space section. Tell your friends, foes, science noobs, and science pros, not just about the channel, but about cosmology in general. Next thing we're going to look at is Cygnus X3. As we regularly look at it, Cygnus X3, one of the more important objects in the Milky Way galaxy, in that it is the most intrinsically bright object visible in the Milky Way galaxy from Earth. Basically, it's jumping up and down and saying, hey, look at me, look at me. Few understand anything about it. It's a high-mass X-ray binary. Here are its X-ray emissions. And if you want to look them up, just head to the Neil Gorell Swift Observatory. Hit Control F for find, type in SIG space X-3, and you'll find this transient chart. And it's actually in a quiescent state again now, sort of in an average emission state in terms of X-ray emissions. And it's important enough that we've created an entire forum thread about it. I would also recommend everybody visit smAshomash.com if you haven't checked it out yet. smAshomash.com. Also, smAshomash.org will redirect you here. You can find our social media links there, as well as links to the forum and the stores. Don't forget to enter the promo code smAsho through Christmas to save 10% at checkout on all orders at both stores. The forum has an entire thread in the Cosmology Forum just about Cygnus X3. If you don't know what Cygnus X3 is, again, the most intrinsically luminous object in the Milky Way galaxy visible from Earth. It's got a radio jet pointed directly at your face, especially if you're in the northern hemisphere. Cygnus X3, massive X-ray binary celestial pole star Deneb. Go have a read about it. It's important enough that we made a shirt specifically about it, and it's also got a diagram of the radio jet. That's the reason why it's so bright. It's an ultra-massive object orbiting a Wolf-Rayet star, which is one of the largest type of stars. The Wolf-Rayet star around which the, quote, little friend is orbiting is large enough that if it were in our solar system, it would be taking up. It would be the size of... Did I miss something? It would be the size of Mars's orbit. Anyway, there's the forum and the Deneb shirt. Again, if you order one, make sure you enter the promo code smAsho at checkout to save 10% on all orders through Christmas. This one is only available in blue spectral colors. You can get it in light blue, medium blue, navy blue, and purple, as it is a massive blue star, part of the summer triangle, Deneb. And that's the end of today's cosmology segment. Let's get on to the basic data that we cover daily. Next, we'll look at the real-time solar wind. And there is the chart for that. It's been pretty steady here over the past 24 hours. Nothing too exciting to report on there. Current solar wind density, around 4 protons per cubic centimeter. Current solar wind speed having dropped below 400 kilometers a second, now at 382 kilometers a second. KP index back to 0. And there's the 3-day chart for the global measurement of geomagnetism. Speaking of geomagnetism, the ground magnetic perturbation maps are back. First, we're going to look at the space-based view. This is based on the Space Weather Modeling Framework. That's 4 hours of data. And you can see a weak magnetosphere here, no surprise there, as again the KP index is at 0. And here are the ground magnetic perturbation maps, which are now animated once again. And thank goodness for that, as there's some interesting stuff happening still as we still see an influx of protons being measured out at the F layer. There goes 16. We'll cover it momentarily. And what's interesting here is we don't see any magnetic perturbations over the Siberian North Pole, mainly over the Canadian North Pole and the South Pole, which has crept into the southern Indian Ocean. And welcome to the polar excursion. Have you found yourself evolving? Are you growing scales? Have you perhaps grown a second spleen? Let us know. Send us your MRI images if you've grown a second spleen. And here's the proton flux over the past 3 days, and you can see it has not yet subsided, although it looks like it is subsiding very slowly. And that started up just after a massive coronal mass ejection and an M-class solar flare, the largest seen in years. There's the 7-day chart. It looks like the peak may have been yesterday, but we'll be keeping an eye on this. And when we say ion, oh well, let's just say hydrogen nuclei. Hydrogen nuclei flying through space at hundreds of kilometers per second really want an electron. I'll just leave it there. They will violently steal an electron from most other molecules, especially in the vacuum of space. We did see a small C-class X-ray flare. C-class flares are now considered small, having come off of a pretty deep solar minimum, although not as deep as the one between solar cycle 23 and solar cycle 24. If you're up before dawn, you may see Venus and Mercury rising before the sun. Also, you may see the second brightest object in the sky, the moon, which is currently in Gemini. Next, here's the diagram of the solar system. There's where things will be in a week. By the way, no massive disasters happened in the year 1200 and some, the last time Jupiter and Saturn aligned perfectly in our sky to form one very bright star-like object. No natural disasters happened. I looked it up. And next we've gone out to stereo A, which is at Lagrange point 5, shown here, to show you Venus. And if you're wondering why it looks so bright, it's because a coronagraph requires a very high contrast. A coronagraph is not designed to look at planets, which are really bright in comparison to the solar corona. So we've got this disk in between stereo A and the sun. Because we want to look at the corona, this is what we use to look for coronal mass ejections facing Earth. And the reason Venus looks so large and bright is because of that contrast. Planets are much brighter than the corona, and that is that. GOES magnetometer is looking a little bit more normal here, as we saw some very high highs and high lows over the past few days. Another indication perhaps that the proton flux is going to subside here, although that's not definitive of anything. And we may be swinging back into the South Pole current sheet momentarily, another indication that the South Solar Polar Field is very strong. So here's the polarization diagram of the current sheet here, showing you North Pole current sheet in green, South Pole current sheet in red. And it looks like the Earth may be getting ready to snap back into the South Pole current sheet. Surprising, especially considering how much activity is showing up south of the equator, the solar equator, that is. Here's the coronal whole field plot, which also shows you the B field. You can see that sudden yank to the south of the B field. And lots of South Pole magnetism shown there in red. And here's a line of sight field plot, which also shows you the active regions there in non-colorized magnetogram. Last but not least, we'll look at the diagram of the coronal magnetic fields. the fields of the sun's atmosphere. And don't be surprised if the crossing to the South Pole current sheet gets delayed here. Keep in mind the magnetic environment can change with absolutely no warning. And these data here are about 2 hours old. Next, we'll check out electrons. We don't see any charging hazards. There's the 1-year chart that's provided from solon.info. NOAA's calling for a small increase in the electron flux here, which will put us back into warning levels if that comes true. We got barely into warning levels yesterday. There's the 3-day chart of the GOES electron flux. And again, this is measured at the F layer, or it's endeavored to be measured at the F layer. And we see anomalous electron content here on the total electron content forecast. We see anomalous electron flux blobs there over the Antarctic continent, as well as a bit over North America. There you can see that kicking up. Surprising levels of electron flux perhaps there over North America. Otherwise, not particularly high levels of electron flux, at least not yet. Again, NOAA forecasting this to get into warning levels a bit today, especially if you're around the equator. Expect to see some GPS errors, especially around noontime. And I've just put up this diagram here once again of the atmosphere. All your weather happens in the troposphere. And the GOES 16 is endeavoring to measure things at the F layer, shown there. It's also showing you the penetration of light into the atmosphere. Note the way most X-rays are adsorbed. That's adsorbed at the mesosphere layer, where visible in IR, infrared light, makes it all the way down to the ground, in an optimal scenario especially. Next, looking at just one slice of it, it's the ionosphere alone. We'll see if it's looking anomalous. It's looking pretty normal here to me. Here's the latest image coming in at 9:45 Universal Time. And we see some oddities here in the deabsorption region here. This is a lower level. We were looking at the F layer. Now we're looking at absorption of the D layer. I'll just go back to the diagram real quick. The D layer shown there, that's the mesosphere. And you can see some radio blackout happening there at the time of that C-class solar flare, as well as ongoing absorption all the way up to 35 megahertz frequency at the South Pole and up to about 10 megahertz frequency in the northern polar region. That flashing looks like a measuring error. I highly doubt that was subsiding and then re-kicking up as fast as it was showing there, looking like anomalous data at the beginning. And I'm just looking here to see if this is going to ramp down or not. And it looks like it is slowly subsiding. A very slow reduction there in this ongoing proton event. And when this ends, the earthquake risk continues for 36 hours. Klyuchevskoye is erupting. We're looking at volcanodiscovery.com. It's producing a 27,000-foot ash plume. Suwanosejima, 4,000-foot ash plume there. Luatolo, flight level 100. It's a 10,000-foot ash plume. Popocatépetl, flight level 200 there. Pacaya back on the list as it explodes down in Guatemala. Fuego's producing sporadic emissions as it mildly explodes. Talica, 5,000-foot ash plume above that exploding volcano. Sangay exploding as well, 24,000-foot ash plume there. And Sabancaya's intermittent emissions and explosive activity are a good reminder to not attempt to do a cartwheel or a tightrope walk across the caldera. Earthquakes of the past 24 are the next segment. We're going to scroll up the list. No major earthquakes. It looks like nothing above a 6 magnitude. And I try to not talk too much about earthquakes. There's a deep one near Timor-Leste. And when I say near, I mean 27.5 kilometers east-northeast of it. It's a 166.7 kilometer deep quake at a 4.8 magnitude. And less than 20 minutes later, a 4.4 deep quake strikes Chile at 122 kilometers. So that's perhaps a related event there, folks. That was at 1:52 Universal Time. There's another deep quake in South America at Argentina. It's a 5.2 at 124 kilometers. Another deep quake in South America. A 4.2 at Peru at 134 kilometers. That one was at 5:15 Universal Time, just a couple of hours before we made the live stream. And did you hear, oh my God, Greenland could be melting. Greenland could be melting, folks, if all kinds of nonsensical climate models come true, and they're not coming true at all. But if they do, oh my God, Greenland could be melting. Please leave us a comment if you remember last summer or this summer when we covered repeatedly the 5 meters of snow from coast to coast on Greenland. Here's another phys.org article. Oh my God, Greenland's ice sheet faces irreversible melting. If only the planet gets warmer, Greenland might melt. Now, the past 3 winters have featured 2 standard deviations above normal snowfall in terms of the 30-year average. 2 standard deviations above normal for 3 winters in a row. 2017 to 2018, 2018 to 2019, 2019 to 2020. Also, all 3 featured 2 standard deviations above normal snowfall in the Northern Hemisphere. Greenland is in the Northern Hemisphere. It's been gaining snow. There's no data to show anything melting on Greenland. All the articles that are talking about this are nonsense. So, now right now, we're only 1 standard deviation above normal snowfall, and I have forecasted that this year will not feature as much snowfall in the Northern Hemisphere as the last 3, and it all has to do with ocean temperatures and heat latency of the planet and the way mankind doesn't even accurately measure the climate. And what am I talking about? Well, most of the Earth's heat latency lies in the water in the oceans. Less than 1% of the Earth's heat latency lies in the atmosphere. So you can measure sea surface temperatures in the atmosphere all day, and you don't know the Earth's climate. You need to know the temperature of the oceans, 3 meters deep, 30 meters deep, 300 meters deep, 1,000 meters deep. If you don't know those temperatures, folks, you don't know the climate. Have you ever gone to the doctor and had the doctor make you blow into a breathalyzer in order to check your temperature? What's that? No. The doctor has to use conduction of heat in order to figure out your temperature. Huh, well, who would have thought? So I just thought I'd put that out there again as, I don't know, I guess most climate scientists haven't taken a basic physics class, since, again, measuring the atmosphere doesn't tell us jack about the climate. Let's continue on. By the way, here's the 2020 snow extent tracker. And look at the graph for 2020. Boy, oh boy, it looks awfully hot. It must be so hot that it's cold, folks. And I've actually heard climate idiots state that, oh, the reason it's so cold is because it's hot. Yeah, for real. So there's snow extent, and you can tell that that is over 1 standard deviation above the average as well. And here's a visualization of how much snow is in the northern hemisphere. It's not even winter yet. It's looking pretty snowy. Let's take a look at Greenland. Oh my God, it's melting. Greenland is melting, folks. Sound the alarm bells. Let's check how much snow is here. Oh, more than 5 meters? Okay. Well, how about over here? How about down here in the southernmost tip? Just the tip. More than 5 meters? Now here we've only got 152 inches, so I'm very worried. Here we've got 182 meters. There's 182 meters. Let's zoom in, because here's what the media is going to tell you. Oh, Greenland's melting. Can I find any place with no snow? Nope. No, I can't. There's 21 inches there. And there's 2.8 inches out in the ocean, an indication that there is sea ice there. Case closed. Greenland could be facing irreversible melting. Oh no! Sound the alarm bells. We're all going to die. And sea levels are going to rise. And Barack Obama and John Kerry's houses are going to be underwater. Oh, I'm so concerned. There's going to be a sudden tsunami. It's just going to rinse John Kerry and Barack Obama and Michelle Obama right into the ocean. I'm very worried about it. Very worried. By the way, it's only 18 days. 18 days and 1.5 minutes till the solstice, when we made the live stream, by the way. And we'll be live streaming during the solstice at the exact moment of the solstice. We'll be doing our daily space weather video, as the solstice will occur on December 21st, Monday. December 21st, Monday at 5:02 Lehigh Valley time. So join us for that. We'll be actually doing an exclusive YouTube stream that day. Twitch users, make sure you subscribe at youtube.com/smAsho. Next, looking at nullschool.net to see what's going on with the jet streams. There are the jet streams of the Eastern world. If I see the word polar vortex one more time on Facebook, I'm going to paper cut my wrists. We've also got the jet stream blowing east to west, which is backwards over the Indian Ocean, once again. Here are the jets of the Western world. And check out the extreme meridional jet stream flow, injecting some frigid air, not the refrigerator manufacturer, frigid air from northern Canada all the way down to Lake Superior there. We've got the jet stream blowing backwards over places like British Columbia as well. Check out the split over the central Atlantic and the anticyclone over the North Atlantic. If you see a clockwise rotation, that's associated with high pressure and anticyclones. Let's look at some more meteorology stuff here. A regular feature of the daily space weather. We provide large global scale snapshots and look for meteorology videos to start coming out in the future. We don't want to step on anybody's toes, but I'm a meteorologist. Because as a pro cyclist, we need to be good at forecasting the weather And I've taken that to the extreme. So perhaps look for meteorology videos coming soon. If you've got some forecast you'd like us to do, let us know in the comments. Perhaps we'll do it during our live stream, which will follow the live premiere on YouTube. It'll be a YouTube exclusive live stream once again, like the one we did yesterday, where we talked about the funding of Dominion voting systems. Yeah. It actually didn't get demonetized somehow. How? I have no idea. Anyway, here's the lightning mapper. And there's lightningmaps.org. And there's quite a lot of lightning strikes happening right now on a global scale. Check that out. A sudden burst. Those all happened at once, folks. Yowzers. That was an epic lightning strike over the North Atlantic. And that was a real-time lightning map, lightningmaps.org. Convince your foes that you're Thor by forecasting thunder at lightningmaps.org. And here's a U.S. Doppler radar map. Some heavy storms there over Missouri, Arkansas, and Louisiana. And some snow falling in the Texas stovepipe. Here's what's going on in the cloud layer. Even though it's not light out enough to see the cloud layer, we use the NASA GOES Interactive Weather Satellite's shortwave radiation map at 3.2 nanometers. I would also note all the low clouds over the Atlantic Ocean. And if you think they're weird looking, I agree. Check out the way the water vapor is behaving. There's the water vapor map for the same area. And you can see while the water vapor is moving very slowly to the east, the clouds are remaining in place. Isn't that interesting? We use the water vapor map because the water vapor map shows us water vapor not even condensed onto clouds. It shows us all the water vapor in the air column. Another feature of the NASA GOES Interactive Weather Satellites. And we encourage our viewers to understand meteorology. If you're a pro driver, you need to understand meteorology. Otherwise, you may find yourself driving into an ice storm. And we're going to zoom in here on southeastern Arkansas to show our viewers down there where those heavy storms are located, what will happen next. So if your Doppler radar is looking questionable, head to the water vapor map. And it will help you out. So we've got multiple systems here. We've got an upper level low here over the Gulf of Mexico, as well as another low and a bunch of dry air mixed in. And it looks like it's going to take its time here a bit. Hope that helps. Now we've got bonus features, including our helioviewer movies. We're also going to show you the colorized magnetogram and the intensitygram. In ultra high resolution. Make sure we're showing it here. By the way, there is an increased risk of large solar flares from sunspot 2786, which is this monster you see here, especially as it moves into this area, as the Earth-facing quiet effect is no longer in effect. So don't be surprised to see large solar flares. I've seen a bunch of magnetic activity happening, leading that sunspot. There's that active region. It does not look like a sunspot yet. Let's take a look at the intensitygram. And I don't see any umbre. I've just refreshed it. There is the time and date stamp. That's from 9:30 Universal Time. There's a sunspot. We've got 3 groups right now. So there's 2786. And I don't memorize numbers. To quote Einstein, never memorize something that you can go look up. Finally, our helioviewer movies that we made as I did show prep. And if I could just hit the correct keys, I'd be showing it to you already. Here's the 304 angstroms full disc. And you can see a prominence in the southeast there, associated with the latest sunspot. I don't remember what number it is. It's not really that relevant, is it? And here's that prominence once again. Look in the southeast right there. Here's a close-up, in case you missed it. And that did not result in a coronal mass ejection. That splashed back down onto the chromosphere. I'll let it play through a second time for you. And we've included the Earth scale there for your viewing pleasure. And now I would like to vanish for your viewing pleasure. A bunch of filaments in the western portion of the sun, as well as associated with that active region there. Here's the 94 angstroms view. And you'll see a totally different scenario for that little prominence there in 94 angstroms. 304 angstroms is helium, ionized helium emission spectra. 94 is one of the many UV emission spectra of ionized iron. I don't memorize that either, as I can go look it up. If you want to know specifically what the ionization states are, go to the SDO page, The Sun Now, and you can click on the information tab there. It'll tell you exactly which ionization state these are. This is another ionization state. It's 335 angstroms. Next, I'd like to thank our patrons, a true source of funding for the content. Please consider becoming a patron at patreon.com/smAsho. We've updated the list. Thanks to our patrons. Again, patreon.com/smAsho. Patrons listed in order of total lifetime contribution. And last but not least, it's the southern hemisphere of our local yellow dwarf in 171 angstroms. Hey, sun, thanks for all of your contributions to life, the universe, and everything. If you've got a comment for the sun, please leave it under the video. Perhaps we'll read it later. And it is about that time. Thanks for tuning in, folks. Remember, stare at that object. Use the proper instruments like the SDO or a solar filter. Don't go blind. Attempt to understand the physics. Welcome to the Neo-Renaissance. Visit our links. And since it'll never be now again, may that solar wind be at your back and that covidiously absent from your location.